In this nugget on exothermic and endothermic reactions, we will look at sketching profiles. Let's start by breaking down the words into their parts. Exo means outside, and thermic means of heat. So in chemistry, an exothermic reaction is one that transfers energy to the surroundings, so the temperature of the surroundings increases. In contrast, endo means inside, and thermic still means heat. So an endothermic reaction is one that transfers energy from the surroundings, so the temperature of the surroundings decreases. In exothermic reactions, the transfer of thermal energy to the surroundings leads to an increase in the temperature of the surroundings. Here, we can see the temperature of the solution increases as the reaction occurs. In endothermic reactions, the transfer of thermal energy from the surroundings leads to a decrease in the temperature, and the solution gets colder. Remember, thermal energy is the energy stored in hot objects and is measured in joules, whereas temperature is a measure of how hot or cold an object is. We can show this information on a graph called a reaction profile or an energy level diagram. We are going to be sketching this graph. Sketching is an informal way of quickly showing the pattern the graph will show, rather than accurately plotting out each point. To draw a reaction profile for an exothermic reaction, first you must draw the lines to mark the energy of the reactants and the products. As we are sketching an exothermic reaction, the energy of the reactants must be higher than the energy of the products. So long as they are, then the sketch will be okay. If you need to show a reaction where the reactants have a lot of energy, you draw the line higher. If they do not have as much energy, you would draw the line lower. And the same for the products. These two lines are then joined, but we can't just draw a straight line between them. We have to draw a line that shows the activation energy. Remember, the activation energy is the minimum amount of energy the reactant particles need when they collide. So we must join the lines with a smooth curve that goes up a bit first before curving down to the products. The difference between the reactants and the peak of the curve is the activation energy. If a reaction has a larger activation energy, you sketch the peak higher. If the activation energy was lower, you'd make the peak lower. The difference between the energy of the reactants and the products tells us the overall energy change. And since this is exothermic, this is energy transferred to the surroundings. For an endothermic reaction, the energy of reactants must be lower than the energy of the products. Again, you can draw these higher or lower depending on the energy levels you need. Again, we must join the lines with a smooth curve, one that goes up a bit first before curving down to the products. The difference between the reactants and the peak of the curve is the activation energy. As before, if a reaction has a larger activation energy, you would sketch the peak higher. If the activation energy was lower, you would make the peak lower. And similarly, the difference between the energy of the reactants and the products tells us the overall energy change. In this case, it is endothermic, so the energy is transferred from the surroundings. To summarize, an exothermic reaction is one that transfers thermal energy to the surroundings, so the temperature of the surroundings increases. The product molecules store less energy than the reactants by the amount transferred. An endothermic reaction transfers energy from the surroundings. The product molecules store more energy than the reactants by the amount transferred. Reaction profiles, also called energy level diagrams, can be used to display the energy changes during a chemical reaction. Keywords: exothermic reaction, a chemical reaction that transfers thermal energy to the surroundings, so the temperature of the surroundings increases. Endothermic reaction, a chemical reaction that transfers thermal energy from the surroundings, so the temperature of the surroundings decreases. Chemical energy, energy stored in chemical bonds. Activation energy, EA, the minimum amount of energy that particles must have to react. Overall energy change, the difference between the energy of the reactants and the products.